Force and motion. Subtopic: speed, velocity, and acceleration. Speed, velocity, and acceleration. If a car travels between 2 points on a road, its average speed can be calculated by the given formula. Average speed is equal to distance moved upon time taken. If distance is measured in meter and time is measured in second, speed is measured in meter per second. For example, if a car moves 90 meter in 3 seconds, its average speed is 30 meter per second. Velocity. Velocity is how fast an object is traveling in a particular direction. So, velocity is a vector measurement. For a motion in a straight line, you can use a positive sign or a negative sign to indicate the direction. For example, positive 10 meter per second is velocity of 10 meter per second to the right, and negative 10 meter per second is the velocity of 10 meter per second to the left. Velocity is speed in a given direction. Quantities such as velocity, which have a direction as well as magnitude, are called as vector quantity. Acceleration. Acceleration is the rate of change of velocity. In other words, how much the velocity of an object changes by every second. Acceleration is given by the equation A is equals v minus u upon t. The unit of acceleration is meter per second square, which means the same thing as meter per second upon second. Things can slow down as well as speed up. Deceleration is nothing but slowing down. It means the change in the velocity is negative. A uniform acceleration means constant or steady acceleration. Motion graphs. A distance time graph shows how the distance of an object from a point changes over a particular time. The gradient of distance time graph gives the speed or velocity. In distance time graph, the distance is plotted on y-axis and time is plotted on x-axis. If a distance time graph is having a horizontal line, it means the object is stationary. If a distance time graph has a straight line, means the object is moving with a constant speed. If the gradient increases, it means the object is accelerating or speeding up. If the gradient decreases, it means the object is slowing down or decelerating. If the line is going down, that means the object is moving backwards. What is speed time graph? Speed time graph shows how speed at different time. The speed is plotted on y-axis and time is plotted on x-axis. The gradient of speed time graph gives the acceleration. Acceleration can be calculated rise upon run, which means y-axis upon x-axis. The area under the curve or the graph gives the distance covered by the object. The horizontal line indicates that the object is moving with constant speed. The distance traveled by an object can be found by determining the area beneath the graph. If the area beneath the graph forms a triangle, the object is accelerating or decelerating. Then area can be calculated by using the formula area is equals half into base into height. If the area beneath the graph is a rectangle, that means moving with constant speed or velocity, then the area can be calculated by the formula area is equals base into height. Recording motion. In laboratory, motion can be investigated by using the trolley shown in the diagram. As trolley travel along the bench, it pulls the length of the paper behind it. The tape passes through the ticker tape timer, which produces dots on the tape at regular intervals. A typical timer produces 50 dots every second. If the dots have equal distance between them, we say the object is moving with a steady speed. If the distance between the dots increases, we say the object is speeding up or accelerating. If the distance between the dots decreases, we say the object is slowing down or decelerating. Free fall. In the absence of air resistance, all objects fall with same acceleration, irrespective of their masses. This acceleration is equal to the gravitational field strength and is approximately 10 meter per second square. So long as air resistance remains insignificant, the speed of the falling object will increase at a steady rate. That means it gets larger the longer it falls. Now here we have an example of a parachutist jumping out of a plane. The graph shows the speed time changes happening when the parachutist is jumping off. Point 1. The parachutist jumps from the aircraft, the parachute is closed, and there is no air resistance acting vertically. As he jumps and starts to accelerate, the force of air resistance also increases. His speed is increasing, but his acceleration is slowing. As the parachutist falls faster, the air resistance increases more. The acceleration is decreasing to zero. The force of gravity is equal to the force of air resistance. Therefore, there is no resultant force, and the parachutist is not accelerating. The parachutist opens his parachute. The force of air resistance shoots up, but the force of gravity stays the same. The parachutist starts to decelerate rapidly. As he slows down, the force of air resistance decreases. The resultant force decreases. Hence, the gradient of the graph and the acceleration both decreases. The force of air resistance is now equal to the force of gravity. The parachutist is falling with a constant speed. This is also called as terminal velocity. The parachutist falls with a constant speed until he reaches the ground.